Okay, welcome. Today we're going to watch a video on more factoring techniques. So go ahead and get your notes out and we'll get ready to go. Okay, our objective today is students will solve higher degree binomials using factoring techniques. Our action today is to solve. How are we going to do it? Or sorry, what are we going to solve? Higher degree binomials. How are we going to do it? Factoring techniques. So we're going to solve higher degree binomials using factoring techniques. Go ahead and pause the video and make sure that gets into your notes. Okay, so what is the degree of the polynomial? That's going to become a major factor in as we move into higher degree polynomials. Okay, we're going to use it to solve, to tell how many solutions, and translate it into graphing. So we need to kind of understand what the degree is. So the definition of the degree is the exponent on the variable of the leading term when the polynomial is written in descending order. One more time. The exponent on the variable of the leading term when the polynomial is written in descending order. So go ahead and pause the video and make sure that gets into your notes. Okay, here's your example. This is 5x to the fourth plus 2x squared plus 3. We notice that it is in descending order, x to the fourth, x squared, and a constant. So this is, if I look at the exponent on the leading term, so the leading term is 5x to the fourth. I notice my exponent is 4. This is a fourth degree polynomial. Now let's look at a non-example. Here's my non-example. If I look at this polynomial, they're saying it's the degree of 2 because their leading term has an exponent of 2. However, if we examine it further, we see this should be the leading term because it's not in descending order. X squared, x fourth, constant, x to the first. This one's all mixed up, so it needed to be written in descending order. This is the true degree. He's just in the wrong order, not this one. So emphasize, polynomial must be written in descending order. Okay, let's look at our first example. And by the way, we are working in section 5.4 of your book. If you need some extra help, you can download that section and take a look at it. Here's our first example. It says factor completely. And we're going to go ahead and probably solve this guy as well. So we want to factor completely. All right, so the first step in factoring is greatest common factor. And as I look at it, I don't see one. So this is a review on factoring. Second step is to determine how many terms to see our method. We have 2 terms. 1, 2. And the only method we know at this point is difference of 2 squares. So as I examine this, I notice I have a minus sign. I have a perfect square and a perfect square. So this, in fact, is a difference of perfect squares. So my special pattern says parentheses, square root each term. Square root of x to the fourth is x squared. Square root of 16 is 4. So this is not new to us. We've done this over and over and over. Sign comes straight down, and then the other one is the opposite. And that's difference of squares. Now, I always emphasize, always look back in and see if you can factor more, and that's where completely comes in, especially with higher powers. Okay, this was a power of 4, and we're used to squares. So if I look at my factors, I notice my first parenthesis is another difference of squares. Minus sign, perfect square, perfect square. So we're going to factor him again. Let's change the color. So the square root term in the first parentheses would be square root of x squared is x and x. Square root of 4 is 2 and 2. Again, sign comes straight down, opposite. Look back in. Now these terms are factored completely. Now if we look at our other side, or other set of parentheses, the common tendency is, oh, difference of squares, but pay close attention and notice that our sign is positive. We don't have a sum of squares. So this, in fact, is factored the best we can do. So factoring completely sometimes means you have to factor more than once. Okay, going to the solving technique. Solving is simply setting each term equal to 0 in solving. So again, this is not new on. Sorry, I have a little lag in my system. There it is. It's back with us. And the first two are pretty easy to see what the solutions are going to be. Add 2 to both sides. My first solution is 2. Subtract 2 from both sides. My second selection is negative 2. Here, I'm going to have to solve. Now remember, this is a quadratic, x squared plus 4 equals 0, by square rooting both sides. So this becomes, let's move this down a bit, x squared is equal to negative 4. I'm using the square root method. And yeah, you could have used quadratic formula on that, complete the square. All the methods are open to us. So we get x is equal to plus or minus. Now the square root of negative 4, that's an imaginary number. That is 2i. So our solutions are, we have two real solutions. We have a positive 2 and a negative 2, so plus or minus 2. And those are our real solutions. We'll put the big R. Then we have two imaginary solutions, plus or minus 2i. Notice how the number of solutions relates to our degree. Okay, that's our example. So go ahead, I'd like you to summarize our steps on what we did. So create yourself a set of steps. So if I give you similar problems, you'll be able to do them. And if you have any questions, we'll talk about them in class.